Step 5.2, distance-based methods. Now we want to look at other cluster algorithms which represent sort of an extension to k-means clustering, and we look at self-organizing maps. There are different implementations of self-organizing maps available for R. We'll be looking at package Kohonen because it has functionality for nice plots in the package. This is a contributed package, so you'll need to install it first before you're able to use it. So we are loading the package. We're setting a seed because there are also some random number generation involved with the algorithm. And self-organizing maps are constructed by using the function sum. And function sum takes as input the data set we want to cluster. And for self-organizing maps, the idea is you not only specify the number of clusters you're interested in, where you want to find the best partition for, but you specify a grid on which you put the cluster centers, and they are then shifted around during the iterative process to find an optimal. So you fix the points sort of in advance to have a certain neighborhood and to have a certain shape. And this is what we're specifying here with the second argument. What do these initial centroids look like, and which positions or locations are they put, and in which grid do we put them? So there's the function sum grid, which is also available in package Kohonen, which does this for us. And we say we want to have 5 rows and 5 columns. So 5 by 5 grid, which means in total we'll have 25 cluster centers. And then the question is, how should these cluster centers be aligned? There is the possibility to have rectangular or hexagonal shapes or grids for self-organizing maps, and here we're using a rectangular grid of 5 by 5 nodes, which are our centroids, which we start the algorithm. And the nice thing is now we can plot this, and the plot visualizes the centroids we found. And the palette name means just in which colors do we want to put the different attributes. So that's the risk data set where we have 6 variables or 6 items, attributes, and we don't want to have a title for the plot. So let's look at that's the default plot for object returns by sum. And this is our grid, our 5 by 5 grid, which has been put on a rectangular shape. And this gives us the representative of each of our cluster. So we detect it, and the area gives us how high is the agreement level. So we see this is the cluster where the people agree to none of the activities, where here they have a high likelihood to agree all of them. And we see also that the locations, because they're in the 5 by 5 grid, we see who are their neighbors.